Hello everyone, let's plot some polar points. We'll find some polar coordinates. We'll do some polar. First thing you got to understand, when you're plotting polar points, you are given a radius and you are given an angle. It's not x, y, it's r theta. So the r is telling you which ring we're on. You can see that these have numbers 1, 2, 3, 4. So 4 is saying we're on the fourth ring. We're on the outside ring there. That was pretty close. And then the other thing is negative 11 pi over 6 is telling you the angle. So it's just like on the unit circle. If it's negative, you're going to go clockwise. So all the way around would be 12 pi over 6 because 12 over 6 is 2 pi. So if we go one less than that, we don't make it all the way around. We go 11 pi over 6 on the fourth ring. That would be the point that we're talking about. Another way you could write that order pair would be 4 comma pi over 6 in polar form. The radius is 4 and the angle is pi over 6. So let's keep doing that. Here's another negative angle. We're on the second ring, and the angle is negative. So 8 pi over 4 is all the way around. We're going to go to negative 7 pi over 4. Another way you could write that would be 1 pi over 4, because this is pi over 4, this angle. Okay, so if the angle is negative, that just means go clockwise. 2 pi over 3 means you're on the second ring, and pi over 3 is right here. So that's 2 comma pi over 3. And then when the radius is negative, this might be the weirdest thing. So first, I start at the angle. If you tell me the radius is negative, I'm going to find 3 pi over 2. And what I'm going to do is kind of visualize this and say, look, this point right there is positive for 3 pi over 2. This point right there is positive 3 pi over 2. This is positive 2. This is positive 1. If you notice, we're going backwards. As I get closer to the origin, I have 4, 3, 2, 1. This would be 0 if I want the radius to be negative. Instead of being here at 3 pi over 2, I'm actually going to go up. This is negative 1, negative 2, negative 3. Right there is negative 4, positive 3 pi over 2. Another way to write that point would be to write it as positive 4, 1 pi over 2. So when the radius is negative, what that means is go to the other side, go through the origin. If this is 3 pi over 2 and the radius is negative, then come up here to pi over 2. That's probably the weirdest thing with graphing polar. So the other thing that we might be asked to do is to convert between polar and rectangular coordinates. Polar is r theta, and when I say rectangular, that's what we're used to, x, y. This is the same skill set as when you're finding vectors. We're finding direction and magnitude. We're just calling it something different. Now it's a radius and an angle. It's the same skills as what we've been doing with vectors, though. So first, you just have to understand that if I'm plotting these in polar, I need to know where 7 pi over 4 is. And I'm going to kind of draw this, and then I'll talk about finding the x and the y. What they're giving me is that the radius is 3. So the radius is 3. And 7 pi over 4 is down here, and that's a 45-degree reference angle. So what they're asking me to do is find x and y using right triangle trig, which is easy to do. Because it's always going to be, if I want to find x, I'll say the cosine of 45 is x over 3. And I'll say the sine of 45 is y over 3, opposite over hypotenuse. So I just multiply using my calculator. Sometimes you can do it without a calculator, but we might as well just use one. 3 cosine 45. Nope, that's not a 5. And 3 sine 45. So they're both 2.12. Why is that? Because this, remember, the sine of 45 is radical 2 over 2, and if you multiply both sides by 3, it's 3 radical 2 over 2. I'll write it as a decimal, though. What was it? 2.12. So the x-coordinate is 2.12, and the y-coordinate is negative 2.12, because you are in the fourth quadrant. You're still below the y-axis when you go back to xy mode. You're in the fourth quadrant, so positive, negative. Let's try another one. 4 pi over 3, so you have to know where that is. 4 pi over 3 is in the third quadrant, down here, and it is a 60-degree reference angle. So this is 60 degrees, and the radius is 2. So now what I'm going to do is my right triangle trig again. I'll say to find x, the cosine of 60 is x over 2, and the sine of 60 is y over 2. So when I multiply both sides by 2, I'll have 2 cosine 60 and 2 sine 60. So 1, and that's radical 3. 1, and I'll just write it as radical 3. So when you have the sine of 60, and you know that the sine of 60 is radical 3 over 2, you just end up crossing out the 2. So this is 1, and then this is, I'll write it as radical 3. But that's not x of y. Since you are in the third quadrant, they're both negative. So it's negative 1, negative radical 3. This is negative 1, and this is negative radical 3. Because you're in the third quadrant, you have to pay attention to the signs. So 2, 5 pi over 6. Again, I'm giving you the radius, which is the hypotenuse, and I'm giving you the angle. Really, what I care about is the reference angle. It's 30 degrees because it's 5 pi over 6. That's 2. So I'll say, to find the x-coordinate, the cosine of 30 is x over 2. The sine of 30 is y over 2. When you multiply, 2 cosine 30, 2 sine 30. Again, the cosine of 30, that's radical 3. So I'm just going to write it as radical 3. So I have x is radical 3, and y is 1. And since you are in the second quadrant, the x is negative, the y is positive. So this is negative radical 3, positive 1. One more going this way. So pi over 4 is in the first quadrant, and pi over 4 is a 45-degree reference angle. So I have a 45-degree reference angle, and the radius is 4. So I'll say the cosine of 45 is x over 4, and the sine of 45 is y over 4. So go back to what we were doing before. Cosine of 45 is radical 2 over 2. If you multiply both sides by 4, these are both going to be 2 radical 2. So y is also 2 radical. So 2 radical 2, 2 radical 2. You can get it as a decimal if you want, but when you can do them without it, it's easier to do it just in your head. 4 times the cosine of 45 is 2 radical 2. See? Okay. So I'll just leave it as an exact answer. That's if I give you the polar and I ask you to go to rectangular. You're always going to be given the radius and the angle. So you can always find the x and the y the same way. The other way is if I give you the rectangular coordinates, so I give you the x, y, and I want r theta. So what they're saying here is they want the radius to be positive and they want the angle to be positive. There's not anything too fancy here. They just don't want negative angles and negative radius. That way we all have the same answer. So if I want to convert to polar coordinates, I'm still going to graph it. I just have to remember that now I'm talking about x and y. This is 0, 3. So in polar, I know that this is 3, the distance is 3, so the radius is 3, and the angle, that is 90 degrees, but in radians, that would be pi over 2, so 3, pi over 2. The second one, it looks like I have x and y are the same, so if x and y are the same, it's isosceles. This is 3 radical 2 over 2, and this is 3 radical 2 over 2, which means this has to be 45 degrees. So I have to do, well, I know my angle is pi over 4, but I have to find the hypotenuse. I got to just do Pythagorean Theorem. So 3 radical 2 over 2 squared plus 3 radical 2 over 2 squared, and I have to square root that. So be careful here. You have to square the 3, that's 9. You have to square the radical 2, that's 2, and you have to square this 2, which is 4. So that's 18 over 4. When you add 18 plus 18, you get 36 over 4. So when you square root that, the square root of 6, the 36 is 6, and the square root of 4 is 2. 6 over 2 is 3. It's 3. So this is 3. Okay? And you can type that into your calculator. It will help you if you want to try. I'll do the square root of 3 radical 2 over 2. So I'm putting that whole thing in parentheses and then squaring it, and then I'm going to do it again. Plus, in parentheses, 3 radical 2 over 2. The whole fraction gets squared. Oops, not that part. Oh no. That. Okay, then I got to delete this. And this. Okay. So you can eventually type it in. It's a little tricky, but you type the whole thing in and then you get 3. So we get the radius is 3. So if we're going to r theta, 3 comma 45 degrees is pi over 4. Okay, so 3 pi over 4. Let's try a couple more. Positive radical 2, negative radical 2. So again, I have a 45-degree reference angle because x and y are the same. So this is radical 2, and this is negative radical 2, which means this is 45. So I will say radical 2 squared plus radical 2 squared. 2 plus 2 is 4. The square root of 4 is 2. So this is 2. And now I will do the angle as the radius is 2. And the angle, because they said they want the angle to be positive up here. So I'm not going to say negative pi over 4. I need to go all the way around, which is 7 pi over 4. Okay, if they specify that the angle needs to be positive, the angle needs to be positive. So make sure you do that correctly. One more. If I give you the x coordinate and then I give you the y coordinate is negative, then I know I am in the fourth quadrant. So I got this guy. This isn't going to be to scale. Let's see, it looks like the x is the longer of the two. It doesn't really matter. Okay, so I have, this is 2 radical 3, and this is negative 2. So first I'll do Pythagorean Theorem. Now, I don't care the fact that that's negative. It doesn't really matter. So I square the 2, that's 4. Square the radical 3, that's 3. And then that's 4. So 12 plus 4 is 16. The square root of 16 is 4. So I have the radius is 4. And now to find the angle, I'll do inverse trig. It doesn't matter which one you do. You probably should be able to see, though, that it's going to be 30 degrees because this ratio is 1/2. So if I do inverse sine, well, I'll do all three of them. Inverse cosine would be 2 radical 3 over 4. 30 degrees. Or inverse sine would be 2 over 4. Opposite over hypotenuse. Or inverse tangent would be 2 over 2 radical 3. It doesn't matter which one you pick. That didn't work, though. We'll do inverse tangent of... Yeah, okay. Whoa. Let's try that again. This is very tricky. 2 radical 3. Look, so you have to put the 2 radical 3 in the denominator or it will try its own order of operations. So be careful. It doesn't matter which trig function you use, as long as you type it in correctly, you get your reference angle of 30 degrees. So if you're going around from 0, that's 11 pi over 6, because 12 pi over 6 would be all the way around. So those are your coordinates. If you can find your coordinates going from polar to rectangular, you can do the same thing with vectors. That's pretty much everything that we need. That's all your delta maths. So go ahead and make sure you get those done, and maybe hit that like and subscribe button.